Hi, in this video I'm going to show you guys a few examples using the laws of logarithms. Okay, the laws of logarithms. Alright, so let's get started. The examples that I have here, they are actually from exercise 4M. Okay, so I have picked a few questions from exercise 4M and I will show you guys how to apply the laws of logarithms to solve them. Alright, so let's get started. So for exercise 4M, question number 1, they want us to write this whole thing as log one thingy, log something. So combine the two log on the left, make it into just log of something, of one. Combine the two log, make them into one. Okay, so 2, combine them and become just 1. Okay, so as you can see, what I have over here, log 5 plus log 6. If I don't see the base is automatically 10. So I have I could use the first root, the first law, to help me out to simplify it. So this becomes log of 5 times 6, which is log 30. Log 30, okay? And that's it. So 2 logs, 2 over here. We started with 2 and we ended up with just 1. So that's what they want us to do, okay? For 1C, same thing. We have 2 over here, 2 logs with 2 of them, and we need to combine them, make it into just log of something. So what I'm going to do here is I will, let's see, I have this 2 over here. I'm going to use the third law to change the way they look right now. Okay, so I'm going to have log 8 to the power of 2 minus log 2 to the power of 4. So I'm bringing this up. Bring that up. Okay, I have a power, I make that power there. So I'm using this rule over there. Okay. So now I will have, and then now I have log 8 squared minus log 2 to the power of 4. I have a subtraction between them. I could use the second one, and I would have. This can be now simplified as, this will be simplified as log of 8 squared divided by 2 to the power of 4. And this can be further simplified, becomes, this will be 64 over 16, so which is equal to log of 4. Okay? So that's it. So I have just expressed 2 logs on the left into 1 log. Okay? Let's continue. Alright, 1e. So 3 log x minus 2 log y. So similarly, I'm going to bring the power up. I will have log x cubed minus log y squared. Okay, and because I have subtraction, I can combine them, and they will be a fraction, x cubed over y squared. Okay, so that's it. That's my answer. All right. Now, for question 2b, pretty much the same thing. And for 2D as well. So from question number 2, I'm going to show you guys 2 examples. So let's get started. I have log 40 to the base of 3 minus log 15 to the base of 3 plus 2 times log 3 over 5 to the base of 3. Right? So let's do one thing at a time. So log 40 to the base of 3 minus log 15 to the base of 3, I could have 40 over 15. And 40 over 15, I can simplify them they get 4 and 3 plus 2 of log 3 over 5 to the base of 3. Alright, so I'm using this property right here. Okay, this one. Alright, so let's clean this up a little bit. So now I have addition. However, when I'm applying the addition, be careful, yeah. When we are applying the addition, you cannot have any coefficient in the front of them. You can't. So be careful with that. So right now I have this plus 2. So before I apply this rule, I need to deal with the 2 first. So I'll have log 4 over 3 to the base of 3 plus log 3 over 5 squared. I'm going to bring this up. Okay, I'm going to bring that up there. Because now I can apply the product, the multiplying, the law about the multiplying. So now this becomes log 4 over 3. Oh, sorry. This becomes 4 over 3 multiplying. So 3 over 5 squared gives us 9 over 25. And we can simplify this. So I will get log 12 over 25. Okay? Be careful with the step over here. This step here. Very, very common mistake, yeah? A lot of students, when they have reached this step, they will automatically combine them. So something like this is a possible mistake that the students make. This is log 3, and then you have 4 over 3 multiply 3 over 5. All right, this is wrong. Okay, that is wrong. You cannot just ignore the 3. Ignore the 2. Yeah, the 2 has to be. You need to deal with the 2 before you can apply the law. Okay, keep in mind. Be careful with that mistake. Very common mistake by the students. Okay, a couple more examples. Now, in this case, we don't have a log, and we don't have a log base of 10 anymore. We have natural log, ln natural log, and ln simply stands for, let's say ln x. That means the same thing as log x to the base of the e, and e is just a number. E is the Euler's number. Euler's number was 2.7182 blah 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 blah. Right? It's just similar to pi, irrational, and irrational number. Okay, irrational number where it does not repeat, and it goes on forever. Okay. So now for this one, how can I express this as one single log? Which means I need to write my answer is going to be something like that. Something like that. Yeah. So let's think about it. And then we have a 2 here. Subtraction, which means I can use something over something. Right? I can do that. But I have a 2 in the front. I have this 2 over here. So I need to deal with that. So this I need to move the 2 up to the exponent. So ln 3 squared minus ln 18. And now I can apply the rule, the law, right? This will be 3 squared gives us 9 over 18. That gives us ln half. Okay? So the laws that we've talked about, they also apply to ln, regardless of what base it is, what base you're taking the log of, whether it is to the number e or to the number of, let's say, x, then the base is actually 10. Right? It doesn't really matter what the base is, but you have to be careful with the form a little bit, okay? Again, this step over here, this 2, that is where students make mistake. So be careful with that. All right. I will show you guys a few more examples in the next video where I will get some questions from exercise 4M and I'll go over them with you. See ya!